The secondary succession of Point Pleasant Park after the devastating Hurricane Juan by Claire Thrower, Amelia Veri, and Jack Zimmerman.
In 2003, when Hurricane Juan hit Point Pleasant Park in Halifax, Nova Scotia, it devastated the forest. Still, it presented a rare opportunity to study and evaluate the effects of a major disturbance on a well-established urban forest and record its recovery. Point Pleasant Park is a combination of hardwoods and softwoods, with most of the hardwood species, including red maple and white birch, on the outskirts of the forest, and the softwoods, most commonly white pine, making up the rest of the forest. Being a significant landmark of Halifax, Point Pleasant Park is very important to the community. Point Pleasant Park is particularly important to the Mi'kmaq Nation. Historically, the location of Point Pleasant Park was called the Place of Spirits, where Mi'kmaq from all over would come and gather 7 days after the first full moon of spring. This area was, and still is, a place of significant importance both culturally and spiritually to the Mi'kmaq Nation. The focus of this evaluation was to monitor Point Pleasant Park forest recovery and shift into secondary succession, using the change to the overall forest community using total density, changes to dominant species using diameter at breast height, and the change in community metric using species richness. The objective of this study is to evaluate how Point Pleasant Park has changed since Hurricane Juan by using total density, diameter at breast height, and species richness to determine changes and possible recovery in the forest community.
In 2004, study sites were established in the park areas that experienced the greatest hurricane disturbance in the forest structure, which can be seen in Figure 2. There are 6 study sites in total, each measuring 20 by 20 meters. Measurements in each replication site were performed annually with the exception of 2005, 2007, and 2020. Every living tree which measured greater or equal to 2.5 centimeters in diameter at breast height was identified and measured. The breast height used in the study to measure diameter at breast height was 4.5 meters off the ground. A meter stick was used to mark this height, while a measuring tape was used to measure the diameter at that height. Various statistical tests were completed to analyze the data from the park, including the datasets from all preceding years in the study, which commenced in 2004. Figures such as total density, species richness, Purlieu's evenness, and Shannon diversity were calculated in each study spot annually, as well as the density of the 2 dominant species, the red maple and the red spruce. All values calculated from all 20 datasets were plotted against time, and regression analyses were completed to test the data's variance compared to the trend line.
As seen in Figure 3, Point Pleasant Park was at its lowest total density post-Hurricane Juan, and since then it has steadily increased every year. The total density of the forest has continued to increase since Hurricane Juan, as shown by the regression analysis results, having a significant p-value. We can reject the null hypothesis that there is no change in the forest community. After losing 70% of canopy cover in Juan, the total density of the forest was incredibly low. Point Pleasant Park has been able to heal better than other urban forests due to it being located in a smaller city, resulting in fewer stressors, and since the visual damage to the forest significantly outweighed the ecological damage to the forest structure. Over the 20 years since the immediate damage of Hurricane Juan, Point Pleasant Park forest has significantly increased in total density. Looking towards the future, based on the steady increase in forest total density, it can be predicted that the forest will continue to increase as Point Pleasant Park forest reach pre-Hurricane Juan density levels and reach their full potential. However, this will be a long process since much of the forest is still classified as immature, which will result in a more evenly aged forest unless other disturbances occur, including hurricanes or human intervention. However, focusing strictly on density and forest recovery, the Point Pleasant Park forest should continue to recover, increase in density, and re-strengthen as an ecosystem.
It was hypothesized that the density of the red spruce in 2004 would not differ significantly from the density of the red spruce in 2024. Through a chi-square test, it was found that the density of red spruce did differ significantly between the years 2004 and 2024. Therefore, we rejected this null hypothesis. As seen in Figure 4, the density of the red spruce per replication site follows a positive trend, such that as the years following the hurricane pass, the red spruce density increases. This being said, the R-squared value was found to be insignificant. Similarly, it was hypothesized that the total density of red maple in 2004 would not differ significantly from the total density in 2024. There was found to be a significant difference between the density of red maple in 2004 and 2024, therefore the null hypothesis was rejected. Similar to the pattern of the red spruce density, the red maple density in Point Pleasant Park increases as time continues preceding Hurricane Juan. Due to the insignificant R-squared value, however, time is not a reliable predictor for the red maple density. As mentioned in the results, 2 species were found to be particularly dominant in Point Pleasant Park throughout the study, the red spruce and the red maple. Although time is not a reliable predictor for either the red spruce or the red maple density in Point Pleasant Park, we can loosely predict the changes to come in the species density as the forest moves towards its climax community. Prior to the disturbance of the hurricane, red spruce was the dominant species in the park while red maple was quite scattered. This dynamic was found to be altered following the hurricane, as both the red spruce and the red maple are now dominating the area. The increase in density of both species is a common event in secondary succession. Following a disturbance, native species tend to increase in density as they begin to fill the newly freed niche. As the canopy was opened by the hurricane, it is possible that any existing red maple seedlings were capable of thriving in the early stages of secondary succession, causing their density to increase. In the future, it is likely these two species will continue to increase towards their carrying capacity. This being said, the intensity of competition often increases as time increases in secondary succession events as more of the environment becomes filled. It is likely that the red spruce will increase in density past the density of the red maple, as it was a dominant species before the hurricane, and therefore likely has some sort of advantage over the red maple.
We use linear regression analysis to further examine the implications of Hurricane Juan on species richness within Point Pleasant Park. Upon measuring 6 different sites of Point Pleasant Park annually between 2004 and 2023, there has been observable growth within species richness, with the average number of species in 2023 being over 4 times the average in 2004. There was a significant positive relationship between time and species richness, suggesting that as time increased, so did the species richness of Point Pleasant Park, resulting in our null hypothesis being rejected. After the destruction Hurricane Juan brought to Halifax, the richness of tree species in surrounding areas was extremely low, with 85% of trees being destroyed in Point Pleasant Park. Of these trees destroyed, entire species had the potential to be removed from Point Pleasant Park due to the limited individual numbers in the population. Presumably, this is what had happened, as in 2004, only an average of 2.5 species were found. Although multiple hurricanes have hit Halifax since, as seen through variances from our linear regression model, Point Pleasant Park has made a steady recovery of species richness. Through different ecological processes, new species or species that were once on the land but were eliminated have grown back in Point Pleasant Park. This data is supported by findings from Keyes, who stated that in 2018, approximately 74% of the forested area in Point Pleasant Park is classified as immature. In the future, as Point Pleasant Park reaches its climax community, the species richness measure is expected to level off at a high number. More species allows for greater biodiversity and stability within their communities. As such, more habitats, food, and resources are available for the environment to prosper and ultimately reach balance, commonly seen through climax communities. Based on the results of our data seen on the current slide, we predict that Point Pleasant Park is in a mid-succession stage. The data presented suggests that the forest has not fully recovered from the disruption and it has not met its climax community. This is seen through the linear growth of species richness, total density, red maple density, and red spruce density, all which have not leveled off yet. Once the climax community, which is the late succession stage, has been reached, the environment will be in balance, with all of our community metrics reaching an equilibrium. It must be acknowledged that Point Pleasant Park is a public urban park, which will indisputably affect the succession rate due to human interference. People walking over new growth limits the prosperity of Point Pleasant, diminishing the amount of growth seen. Secondly, over the last 100 years, Point Pleasant Park rangers have been removing woody debris due to the human use of the park. It is believed that by removing the natural debris, the soil has been lacking nutrients, not allowing for the forest to replace itself when needed. These examples of human interference may contribute to the large variance seen in some of our data, specifically the density of red spruce and red maple trees. When discussing the regeneration of Point Pleasant Park, Indigenous knowledge and practices must hold importance in the conversation. Wisdom passed down by late Micmac chief Charles Labrador, known as Trees Holding Hands, allows us to view Point Pleasant Park as a living community, one that is entitled to the respect we show human communities. This wisdom depicts the tree's roots as hands being held together, just like us humans do. Understanding forests in this way will aid the recovery of Point Pleasant Park to its mature state.
By studying the ecological changes after Hurricane Juan, we can see Point Pleasant Park forest's recovery and entry into secondary succession. The forest is mainly made up of a few species of trees: red maple, white birch, and pine. Having a few dominant species is a characteristic of secondary succession, since these are the pioneer species that can recover quickly after disturbance. So while the forest density may be recovering, the diversity of species can go down, since the species that recover from disaster will be the dominant species in a secondary succession forest. This does not mean that other tree species can never come back to the forest, but they will have a higher level of competition.
The second question is, do you believe that Point Pleasant Park will return to its former level of tree biomass before the hurricane? The process of secondary succession differs from primary succession, as soil and nutrients are already present in the area due to the presence of previous species. This factor alone makes a complete recovery from the disturbance much more likely. Although Point Pleasant Park experienced catastrophic damage during this extreme weather event, it is quite possible that the park will return to its former level of tree biomass with time. Secondary succession allows for the recolonization of plant species, which can lead to the restoration of biomass, although the population dynamics may differ. As mentioned previously, secondary succession allows for the opportunity for differing species to dominate given the newly cleared niche. Therefore, as the forest reaches its climax community, the composition of the forest may not be identical to the community previous to the hurricane. It will be difficult to predict the timeline of this restoration, as none of these markers in a study can be accurately predicted using time alone. Various other factors such as future weather patterns, human activity disturbances, and community restoration efforts will determine the timeline of the recovery of the forest.
Our third question asks us to expand on how exactly the guiding principle of trees holding hands helps the park. The wisdom provided to us by Charles Labrador, as seen in Figure 10, is meant to make people draw respect to the land before any knowledge of it is shared. Acknowledging the forest as a living system, one that interacts with each other just like humans do, for example by holding hands, will draw us to treat forests with the respect they deserve. This causes us to understand forests as not just a place with trees and animals, but a place full of life. Charles Labrador himself said, "Go into the forest. You see the birch, maple, pine. Look underground, and all those trees are holding hands." When viewing Point Pleasant Park through this wisdom, users of the park will do so with appreciation in all aspects. Whether it be through dog walkers disposing of waste properly, litter prevention, new park legislation, or even studies like this being conducted in a way of respect towards the land, every action will help aid Point Pleasant Park to recovery.
We would like to acknowledge the work done by Christine Beauchamp to establish this ongoing experiment which allows students to view a secondary succession event firsthand, as well as Allison Schmidt for continuing the study. We would also like to recognize the help of all the TAs and instructors, as well as the Bio 2060 students who collected the data in the fall. Finally, we would like to acknowledge the flora and fauna in Point Pleasant Park, without which we would not have a study at all.